Let's talk a little more about equivalent ratios. Once again, a ratio is, and we're going to use a word that you might not have heard before, multiplicative. This means you can multiply it. It is a multiplicative comparison of two quantities which describe the same attribute. They can be written three ways. Remember, we have the word two, we have the colon, and we have the fraction bar. And those are our three ways. Equivalent ratios. These are ratios that are equivalent, can be simplified to the same value. So here, they multiplied by 2, and here they multiplied by 3. Here they multiplied by 2, and here they multiplied by 3. Now remember, we can also move backwards. So if you're looking at this one here, you could say that they divided by 3. Let's go ahead and make a couple. Right here we have the ratio 7 to 11. Remember, whatever you do to one side of the ratio, you have to do to the other side. So I'm going to multiply by 2. So I'm going to say 7 times 2 is 14. 11 times 2 is 22. And there we go. There's one equivalent ratio. Now you can do whatever you want for the next one. You can multiply by 3. You can multiply by 5. You can multiply by 10. Anything that's going to be really easy. And so I'm going to multiply by 3. 7 times 3 is 21. 11 times 3 is 33, and I have made two equivalent ratios. Right here with 18 and 12, well, this first one, I see they're both even, so I'm going to divide by 2. 18 divided by 2 is 9. 12 divided by 2 is 6. And there's one equivalent ratio. I could also try dividing by 3. 18 divided by 3 is 6. 12 divided by 3 is 4. Either one of those. I could have multiplied and gotten another equivalent fraction. There's no limit to the number of equivalent fractions that you can find, or equivalent ratios. Try 6 and 10. Well, I see they're both even, so I'm going to divide by 2. 6 divided by 2 is 3, and 10 divided by 2 is 5. Then I'm going to do a really simple one. I'm going to multiply them by 2. 6 times 2 is 12, and 10 times 2 is 20. So there's two equivalent ratios right there. Now I want to know if these are equivalent. So I'm going to look at it and I'm going to think to myself, what can I do multiply 2 by to get to 8? Well, I know 2 times 4 gives me 8. So then I'm going to go down here and say, okay, does 5 times 4 equal 20? It does. So the answer is yes. They are equivalent, and if you wanted to find the multiplier or scale factor, that is this right here. Our scale factor is 4, or our multiplier is 4. Now I need to look, and I'm going to think here, and I'm going to say, oh, well, I'm getting smaller, so I know I'm dividing. 12 divided by what gives me 6? Well, I know 2. So then I'm going to go down here, and 4 divided by 2, does that give me 3? No, it would have given me 2. So these are not equivalent. These are not equivalent. Now this one is kind of tricky. Let's look here. 8 times what, because I'm getting larger, can give me 20? Well, I don't know off the top of my head, but I could divide to figure it out. So 8 goes into 22 times. That's 16, leaves me with a 4. I'm going to add a decimal. 8 can go into 45 times. Okay. So I'm multiplying by 2.5. All right. Now I need to go, okay, well, 6 times 2.5, oops, sorry. 6 times 2.5, does that give me 15? Well, let's find out. I'm going to put 2.5 on top and multiply by 6. That gives me 30. And then 6 times 2 is 12, plus 3 is 15, and 1 place for my decimal. So that gives me 15. So that is right. So yes, these are equivalent. And my multiplier, or my scale factor, would have been 2.5. So your scale, or your equivalent fractions or equivalent ratios, can be multiplied by a decimal or a fraction. Please remember that. Your next page is the Khan Academy for equivalent ratios. I want you to make sure that you get the score you need and you document your scores. Also, if you realize that you may have made a mistake on your equivalent fractions on a previous worksheet, go ahead and go back and work on that now.